Hello students, this is Miss Mishu, and this is your compound interest lesson number 1. So the objectives are students will be able to calculate compound interest using the compound interest formula. Let's review some terms you've already heard and one new term. Remember, interest is money paid regularly at a regular rate for the use of money lent. The principal is the amount of money that's invested or borrowed. The term or the time is the time frame money is invested or borrowed. And a new term, at maturity, means at the end of the term. I think it's important for you to get an online calculator that does exponents, like y to the x, or has a little caret. You can use your phone if you want to, but here's a good link for a scientific calculator. And I'll clear this one here to get ready to use it. All right. So this is the compound interest formula, and it is a little bit more complex than the simple interest formula. It's A, that stands for the compound amount. So that's what that investment is worth at maturity. Remember, at maturity means at the end of the term, is equal to P, 1 plus R over N raised to the NT. So the P stands for the principal. 1 is a stagnant number, stays the same, plus the interest rate over how it's compounded, okay? So this is the number of compounding periods, also known as compound frequency. And it's raised to the number of periods times the time. So once we plug numbers in here, I think you'll get the hang of it. How often can something be compounded? Well, this is when you add interest on the original interest that you've earned. So you add it to the original principal, and it begins to add up a lot more over time than simple interest. So daily is 365, biweekly is 26, monthly, that'll be 12 times within a year, quarterly, 4 times within a year, semi-annually, twice, and annually, of course, is once a year. So the compound interest formula is really very useful and time saving because if you didn't have the compound interest formula, you would have to do each step out manually. For example, assume that you invest $1,000 at 2% compounded quarterly for a year. So you start with the principal. Remember, the I is equal to PRT. So if we didn't have compound interest, it'd be principal times rate, and then the time is a quarter of a year. So if you multiply those things out, you would earn $5 within that first quarter. Okay? Quarterly means 4 times a year. So then your new principal at the beginning of the second quarter is 1,005. You multiply that by 0.02. Again, by 0.25 because it's a quarter of a year. That second quarter, you would earn $5.03. Turn around and add that to the original principal, and it's 10.10.03. And then multiply by 0.02, multiply by 0.25. That third quarter, you would earn $5.05. Then you would add that to the previous balance, ending up with 1,015.08. Multiply by 0.02, multiplied by 0.25, you'd end up with $5.08, and then you add that to the previous balance. So that amount becomes $1,020.16. So basically, that's a lot to do, and that's just compounded quarterly for a year. Can you imagine if it's compounded daily, which is 365 times? So let's just do that. Clear this calculator. So 365, let's say it was daily for 5 years. You would have to do that 1,825 times. So that's why this formula really helps out. It's a lot faster. So in this instance, the $1,000 is the principal. The 2% is the interest rate. It's compounded quarterly, so that's the N, okay? The R is the rate, the N is the compound frequency, And it's compounded quarterly, which is 4 times the time, which is just 1 year. So 4 times 1 is 4. So if we did this out on the calculator here, work within the parentheses first, okay? So I would do it this way. I really, really strongly suggest you do it this way so you get more of an accurate answer. So you work within the parentheses first. So you have 0.02 divided by 4. So it's 0.02 divided by 4. And then click equals. Equals. Then we're going to add 1 because that's part of this. 0.02 divided by 4 equals plus 1. The next step is to raise it to the 4th power. So it's y to the x, 4 equals. And the final step is to multiply it by the principal. So multiply by 1,000 equals $1,020.15. So clearly you see that this is a lot faster than doing the long way, even more so if you get into daily compounding where you'll earn more money. So let's go on to the next slide. Open up your sheet and let's do this problem. I believe this is the same as the one before. It's really important that you show your work, okay? So let's just show it out on this paper. 0.02 divided by 4 equals plus 1 equals, then x to the y 4 equals, then multiply it by 1,000. This is the one we just did. So it's $1,020.15. Always pay attention to the word that follows compounded because that's your N. That's your N. Okay? So let's try number 2. Assume you invest $500 in an account that earns 5% interest compounded quarterly for 5 years. What is the investment worth at maturity? So this is at the end of the term. So you want to plug things into the compound interest formula. I've also placed it over here. So what's the principal? It's 500. 1 is a constant. The interest rate is 5%, so that's 0.05. How is it compounded? It's compounded quarterly. Okay, so that's going to be your N. Your NT right up here. So how it's compounded, that's your N. Your time is 5 years. So 4 times 5, this exponent here will be 20. So work within the parentheses first. I would, again, strongly recommend you do it this way. I'm going to clear the calculator. 0.05 divided by 4 equals plus 1 equals. So we've just done what's inside these parentheses. Now we need to do the exponent. Y to the x, 20 equals. And then finally multiply it by your principal of $500. And you should get $641.02. Remember, if this third number to the right of the decimals, 5 or above, you give that one a shove. Okay, let's try number 3. Assume you invest $1,500 in an account that earns 6% interest compounded monthly for 6 years. What is the investment worth at maturity? Pay special attention to what follows compounded. That is the N. So take some time and try to write out the formula on your sheet now. Thinking, okay, what's the principal? What's the interest rate? How is it compounded? And then it's raised to the NT. Okay, so A is equal to P, 1 plus R to the N raised to the NT. So that is 1,500, 1 plus 0.06 divided by 12 because it's compounded monthly. And then the 72 is, it's compounded monthly for 6 years. So 12 times 6 is 72. Oh, and we need to go back one. Sorry about that. Here we go. Sorry about that. Okay, so when you plug these numbers in, again, I'm going to clear the calculator. It's 0.06. Clear. 0.06 divided by 12 equals plus 1 equals. Then the next, that's what we've done right within the parentheses. We're going to raise it to the 72nd power. So y to the x 72 equals, and then the final step is to multiply it by the principal. So that's where you get $2,148.07. Remember, this third number is 5 or above, so you want to give this one here a shove at 7 cents. Okay, let's try number 4. Assume you invest $10,000 at 4% compounded daily for 5 years. How much money will you have at maturity? So plug the numbers into the formula. 10,000 is the principal, 1 is a constant, it's 4%, daily is 365 times. I would do this number out on a calculator first, okay? So it's compounded daily, which is 365. Whoops, clear that. It's 365 compounded daily for 5 years. So it's compounded 1,825 times. Okay, so what you do is work within the parentheses first. 0.04. I don't think I put the 185 there. There it is. Okay, let me try that again. Okay, so it's 0.04 divided by 365 because it's compounded daily. Add your 1. You're going to raise it to 1,825. Then you're going to multiply by the principal, 10,000. So your answer is $12,213.89. We're going to try one more together, and then I'll let you do the last 5 on your own. You invest $5,000 in an account that earns 5% interest compounded monthly for 6 years. What is the investment at maturity? Again, you want to use the compound interest formula. This is the principal. This is the R, the interest rate, 0.05. It's compounded monthly, so that's your N. And the T is the amount of time, which is 6 years. You must show your work. So that's the formula. So the 5,000 is the principal, 1's a constant, 0.05 is the interest rate. It's compounded monthly, so that's your N. It's compounded monthly for 6 years, so 12 times 6 is 72, that's your NT. So again, work within the parentheses first, 0.05 divided by 12. You should hit equal, so you get more of an accurate answer, plus 1 equals, and x to the y, 72. Your final step is to multiply it by the principal. So your answer should be $6,745.09. Again, this third number is 5 or above, so this becomes 9. You give that a shove. So on your document, we've done 1 through 5 together. I would like you to do 6 through 10 and then submit this by the due date. Hopefully you learned a little bit more about compound interest. Give it some time. It is a little bit more challenging than simple, but I think you can do it. Reach out if you have any questions, okay? Have a great day.